This is the last section in Unit 5. It's been a very tough unit, but this section, you're just looking at formulas and applying the formulas. In calculus, you're going to need to know these formulas. Every once in a while, they pop up. So we're given sine of 2u. So if the angle is u, say the angle is 30 degrees, and I wanted to find the angle of 60 degrees. I could use 2 times 30, give me 60 degrees, and that would be 2 times sine of 30 times cosine of 30. That's the process. But we're going to use this with only radian measure. So once again, you do not need to memorize these formulas. These formulas will be given to you. In calculus, it's something that will pop up occasionally, and you'd have to have them memorized. So my first example, I'm given sine of theta equals -4/9, and theta is between pi over 2 and 3 pi over 2. So this means this is between the second quadrant and the third quadrant. But sine is negative in the third quadrant. So I've drawn my triangle in the third quadrant. I've labeled the opposite side -4, and my hypotenuse is 9. Remember, hypotenuse will never, ever, ever be a negative number. Then I use -4 squared plus x squared equals 9 squared. So x squared equals 81 minus 16. So that's where I got plus or minus the square root of 65. But since I know that I'm going left, it has to be the negative. Then I just go into my formula. Sine of 2 theta equals 2 sine theta cosine theta. This is theta, so I can look right at my diagram. I have 2. The sine of theta is what I was given, -4/9. Cosine of theta is what I can look at the triangle, -65, negative square root of 65 over 9. Put that there. I multiply straight across. Numerator, 2 times -4 is -8. -8 multiplied by negative square root of 65 is going to be a positive 8 square root of 65. 1 times 9 is 81. And there's nothing else I could do with it. That's my answer. My next example, I'm given cosine of theta equals the square root of 2 over 5, and I know that the angle is between the first and second quadrant. Since cosine is positive, it has to be in the first quadrant. So I've drawn my triangle in the first quadrant. My adjacent side is the square root of 2. My hypotenuse is 5. So I know the square root of 2 squared plus y squared equals 25. So y squared equals 25 minus 2. Y squared equals 23. So that's how I got the square root of 23, and I know it has to be positive because I went up. And I use my formulas. There are 3 different formulas for cosine. The first one is the real one. The other ones were just derived by replacing it, and I'll show you on the equations how it can be derived. Filling in everything. So cosine, square root of 2 over 5, I square that. Minus the sine, square root of 23 over 5, I square that. Square root of 2 squared is 2. 5 squared is 25. Square root of 23 squared is 23. 5 squared is 25. So 2 minus 23 is -21 over 25. And then just like the sum and difference formulas, tangent people like least often, but it's because you have a fraction going on. So my problem is tangent of theta equals -3 over 7, and I know my sine is less than 0. So tangent's negative in the second and fourth quadrant. Sine is negative in the third and fourth quadrant. So I know that this has to be in the fourth quadrant. So I've drawn my triangle in the fourth quadrant. So I know my opposite side is the 3. It has to be the negative because I'm going down. My adjacent side is the 7. I do 7 squared plus -3 squared equals c squared. So 49 plus 9 equals c squared. This is 58 equals c squared. So then I'm going to do my square root of 58. that doesn't, my answer up there doesn't make sense. It's 2 times 29, so I think I made a mistake on it. Let me go ahead and fix this. Yeah, that doesn't make any sense. So I can actually replace this. It's going to be the square root of 58. Glad I caught that mistake. And it's not going to make a difference at all because I'm using only tangents, so it doesn't make a difference in my answer. And it's never going to be plus or minus because it's a hypotenuse. It's always a positive, so I don't have to worry about that either. So I've got tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. So I didn't even need this at all. So tangent of theta would be negative 3 over 7, so 2 times negative 3 over 7. 1 minus negative 3 over 7 squared. 2 times negative 3 over 7 is going to be negative 6 over 7. When I square negative 3/7, I get a positive 9 over 49. Negative 6/7, 1 minus 9 over 49 gives me 49 over 49. Minus 9 over 49 gives me 40 over 49. When I divide by a fraction, I flip and multiply. So negative 6 over 7 times 49 over 40. And I really hope that you don't pick up a calculator for everything that you do in here. You're at a disadvantage later on. I'll show you what I do. 7 goes into 49 7 times. So I cross off that 7, I put a 7 there. 6 and 40 can be reduced. So 6 can be reduced in half. So this would be negative 3. Take half of that, I get 20. So negative 3 times 7 gives me my negative 21, and 1 times 20 gives me my 20. If that bothers you and you must pick up your calculator, you're fine, but as you go higher in math, you are expected to be able to do math without a calculator. So be very careful. Then we're going to use these to solve equations. So this example is I have 2 cosine x plus sine 2x equals 0. I'm going to solve this equation, but the first step I have to do is this is an x and this is a 2x. So that's not good. I need to get rid of it so that I'm going to replace sine 2x with 2 sine x cosine x. So 2 cosine x plus 2 sine x cosine x. I can factor out a 2 cosine x because it's the greatest common factor. Now it's just like a problem we did before. Once I factor it, I set each factor equal to 0. 2 cosine x equals 0. 1 plus sine x equals 0. If 2 cosine x equals 0, cosine x equals 0. Cosine x is going to equal 0 at pi over 2 and 3 pi over 2. 1 plus sine x equals 0, so sine x equals negative 1. Sine of x is equal to negative 1 when x is equal to 3 pi over 2. And you can box it if you want. I already have it here, so I'm not worried about it. Last example. Cosine of 2x plus cosine x plus 1 equals 0. Here's the problem. I have a 2x here and I have an x. So I can't solve this the way I did it before. I'm going to have to replace cosine 2x. And I'll show you where they derive the other equation. Since cosine 2x equals cosine squared x minus sine squared x, and because sine squared x plus cosine squared x equals 1, if I replace sine squared x with what I can solve this for, and we've done this before, that's where I get the 1 minus cosine squared x. That's minus everything, so I make sure I distribute the minus sign. Combine like terms, so that gives me 2 cosine squared x minus 1. So that's where they derive the formulas. Now I can use this 2 cosine squared x minus 1 in my problem. So 2 cosine squared x minus 1 plus cosine x plus 1. I combine like terms, so a negative 1 and a positive 1 is 0. 2 cosine squared x plus cosine x equals 0. Solve this just like I did before. Factor out a cosine x. Make sure when you factor, you double check that you've gotten it factored correctly, because if you factor it wrong, your problem's going to be wrong. Cosine x multiplied by 2 cosine x gives me 2 cosine squared x. Cosine x multiplied by 1 gives me cosine x. Set each factor equal to 0. Cosine x is equal to 0 at pi over 2 and 3 pi over 2. When I solve this for cosine x, I get cosine x equals negative 1/2. Cosine x is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. And that's how you do the last unit in Unit 5, the last section in Unit 5.